and hello and welcome to the next video number 4 on integration. uh, I think 7 or 8 days before I have posted two videos, part number 46 and 47, based on NCERT exercise 7.4 and 7.5. Now here we have to start NCERT exercise 7.6. It is based on by parts. So very first question I am going to take is simple, x sin x dx. As you know, अगर आपकी याददाश्त थोड़ी कमज़ोर हो तो मैं बताऊं कि आइलेट हम लोग लिख लेते हैं. देयर शुड बी टू फंक्शंस, वन इज डिफरेंशिएटिंग फंक्शंस, सेकंड वन इज इंटीग्रेटिंग. जिसको हम आसानी से इंटीग्रेट कर सके उसको इंटीग्रेटिंग लेना चाहिए. यहाँ पर दोनों को हम कर सकते हैं. इन दैट केस differentiating x we get 1, so it better algebra and trigonometry we have. So this is a first function. So first function को बाहर रखा, इंटीग्रेशन किया sin x dx, then minus integration over ddx of first function into integration of second function or into dx. So what we get, x minus cos x. Okay, minus cos x makes it plus. ddx of x is 1, so here only cos x dx. So it is minus x cos x, and then again integration of cos x is sin x. So this question is based on what? Integrating by parts, or you can say by product rule. Okay, next question, that is the third one. Here x square ex dx. Now again let's say algebra exponential. So I just take x square as first function, ex as second function. So x square into integration over ex dx minus integration over ddx of x square, integration of ex dx, and then whole dx. Okay, now what we have, integration of ex is ex, so x square ex minus 2x ex and dx. Again in this part we have to do integration by parts. Okay, x square ex minus 2 is common, x integration over ex dx minus ddx of x, integration of ex dx, and then whole dx. So x square ex minus 2x ex minus minus plus 2, ddx of x is 1, and integration of ex is ex dx. Okay, so what we have, you just see x square ex minus 2x ex plus 2ex and plus c, where c is constant of integration. So you can take here ex as common, and then it is x square minus 2x plus 2 and plus c, where c is constant of integration. Is it? So this is what I have done, two questions based on integration by parts. Moving towards the next question, I am going to take, I think, question number 11. Question number 11, which is integration over x cos inverse x by root under 1 minus x square. Okay, here I am going to let by substitution cos inverse x as t. So integration is what? On differentiation we find that minus 1 by root under 1 minus x square dx is dt. So this positive dx by root under 1 minus x square is minus dt. Okay, and from here x is what? Cos t. So the integration becomes cos x is t, cos inverse x is t, and x is cos t, and the rest is of minus dt. So t cos t dt with minus sign outside. As I have done the very first question, x sin x dx, like that one, you can do it. Minus t integration over cos t dt minus ddt of t integration of cos t dt, and the whole product का फिर से integration this one. Okay, from here what we get? Minus the integration of cos t is sin t, minus minus plus ddt of t is 1, so 1, and cos t का sin t dt. Then at last it is minus t sin t, and integration of sin t is minus cos t and plus c. Now here don't leave the answer, because t is not our variable is x, so convert into what? Into x. So wherever t is it cos inverse x. But what about sin t? Cos t is x, then sin t, if cos t is x, then sin t is nothing but 1 minus cos t square, that is root under 1 minus x square, is not it? So in the next part we just write down minus t sin t. In place of sin t is it 1 minus x square, in place of t it is cos inverse x, minus cos t is x, and plus c, where c is constant of integration, that is the answer. Okay, so here we have done, I have done three questions. Moving towards the next question, that is question number 10, sin inverse x whole square. So again I am going to let that sin inverse x as t, certainly, and then on differentiation it is root under 1 minus x square dx dt, but again I am saying that dx only. So root under, what is t? T is sin x. Okay, so root under 1 minus x square, sorry, sin t is here, sin t is x, so root under 1 minus x square is 1 minus sin t square, that is cos t. So you can say dx is nothing but cos t dt. So what happened? This is t square, and in place of dx it is cos t dt. Okay, cos t dt. So again, as we have done the third question, that is x square e square, what we have to do, t square cos t dt minus ddt of t square integration of cos t dt, and then whole dt integration, that is t square sin t minus 2t sin t dt, 2t sin t dt. From here I can say minus 2 t sin t, again by parts, in this here by parts, sin t dt minus ddt of t integration of sin t dt and whole dt, and complete. So this way we get the t square sin t minus 2, sin t is minus cos t, integration of sin t is minus cos t, minus minus plus 2t cos t. Again here integration of sin t is minus cos t, to minus minus and minus, so minus 2 t ka differentiation 1, so 1, that is cos t dt. Okay, so to end, in terms of t, sin t square sin t plus 2t cos t minus again cos t ka integration sin t, so 2 sin t and plus c. Now just replace all t's in terms of x, all t's in terms of x. So what we have to do, that t square, what is sin t? Sin t is x. So sin t is x. T square. T is sin inverse x. Sin inverse x whole square plus 2t cos t. 2. What is cos t? So certainly cos t is root under 1 minus x square. So 1 minus x square, and in place of t it is sin inverse x minus 2 sin t is x and plus c, where c is constant of integration. Am I right? Taking one more question. Tan inverse x dx. Okay. Here you take as like this one. One is 1, another is tan inverse x dx. Algebra inverse. So I tan inverse x तो निकालना है, इसलिए very first choice is that it should be differentiating function. 1 की जगह dx minus ddx of tan inverse x, integration of dx and then whole dx. What do we have? Integration of dx is x. So x tan inverse x minus integration of ds is x, and ddx of tan inverse x is 1 by 1 plus x square. Okay. Now we are in exercise 7. We are just covered a lot. So very much we can see that if we take 1 plus x square as t, 2x dx should be dt. Here is x dx. So if we take like multiply half outside the integration and 2 inside the integration, you can say if you take x square as t, 2x dx as dt. So this is nothing but, whenever you find in denominator of function and its differentiation is in the numerator, you can write down it is log of 1 plus x square dx and plus c. This is the answer of the question. Am I right? So this is what I have done, 4 or 5 questions. Now moving towards some another part of the integration, I have given you the idea about one of the type, that is if a function in the form of ex fx plus f dash x dx, it is simply, if it is 1 marks question, you should write down. But how you can get it by that, if you integrate it by parts, ex fx, you will get in the next part. जैसे हमने अगर इसको ex fx को केवल by parts करना हो, तो fx लीव किया, ex dx and then minus ddx of fx is f dash x हो जाना है अगले स्टेप में. ठीक है. So what we have, ex fx and minus integration of ex is ex and f dash x x. So integration of that part is this one, and plus this ex f dash x integration. So these two cancel, we are left with this one. So the answer of this question is ex fx plus c. But how can you do if it is given of 1 marks question? Okay, you should write down. You have to just observe which function is fx and which one is f dash x, and then do the rest. As we are moving towards the next question, you will see. First I am going to take a very simple question. Ex sin x plus cos x dx. Here you find if fx as sin x, f dash x is what? Cos x. So the answer should be ex sin x plus c. How? I am going to do in the next question, not in the same question. Okay, just I am taking ex 1 by x minus 1 by x square dx. नाउ इसको मैं एक्सप्लेन करके बताना चाह रहा हूं कैसे ये होगा, ठीक। सो अगेन if you observe that 1 by x is fx, then certainly its derivative is nothing but minus 1 by x square. So my advice, take this to be integrate and this one just carry forward. ex जो f dash x का पार्ट हो उसको केवल कैरी फॉरवर्ड करेंगे. नाउ here integrating by parts, 1 by x as algebraic function, the first function, integration of second function, minus differentiation of 1 by x, integration of ex dx, and altogether dx, and one which is carry forward, that ex by x square dx. Okay, now moving towards next step, 1 by x ex, you can write 1 by x into ex. Okay, minus, what is the differentiation of 1 by x? It is minus 1 by x square. So write down, integration तो है ही पहले, 1 by x square, integration of ex is ex dx, and it is minus ex by x square. This part is carried forward and this is from the first integration. Now what do we see? These two are same. So the answer is ex by x and plus c, where c is constant of integration. It is running outside, so maybe some thundering, but okay, well and good. So this is the second question I have taken based on. Now I am going to take one more question. The question is integration over ex 1 plus sin x by 1 plus cos x. If you have some idea about the trigonometric identities of class 11, you certainly jump over that it should be 1 by 1 plus cos x plus sin x by 1 plus cos x as y. You will find in the next step, it is 1 plus cos x is 2 cos square x by 2. Okay, sin x is 2 sin x by 2 cos x by 2, and again 1 plus cos square is 2 cos square x by 2. You can see here that here I am going to take it as sec square x by 2 into 1 by 2, and plus 2 cancel, 1 cos x cancel, so next is tan x by 2. So here in this case fx is tan x by 2, then its derivative f dash x is tan sec square x by 2, and then x by 2 का 1 by 2. So this one is fx and this whole is f dash x. So क्या करेंगे अगले स्टेप में कि हम लोग इंटीग्रेट करेंगे इसको, इस पार्ट को, और इस पार्ट को जो कि हाफ इंटीग्रेशन ऑफ ex sec square x by 2 dx है, इसको कैरी फॉरवर्ड करेंगे. I am going in detail. Otherwise, if it is a 2 marks question now and we have done 1 or 2 steps, so from here you can write down the answer is ex tan x by 2 plus c by using integration over ex bracketed 1 fx plus f dash x dx as ex fx plus c. So, but I am going to do it in detail so that you can understand about that, how can it be. So this very first part, tan x by 2 as differentiating factor, ex integrating factor, minus ddx of tan x by 2, integration of ex dx, whole integration. This is the integration of very first, and now second is as usual carry forward, ex sec square x by 2 dx. Okay, so what should be the next step? Next step is ex tan x by 2 and minus ddx of tan x by 2 is sec square x by 2, and since x by 2 is other than x, so chain rule, applying chain rule, you will get the ddx half, and integration of ex is ex, and the whole integration dx plus half ex sec square x by 2 dx. What do you see here? Half half, sec square x by 2, sec square x by 2, ex dx. So these two are the same, minus and plus. So the answer is ex tan x by 2 plus c, where c is constant of integration. All these is not it. Now moving towards one more question. X minus 3 ex x minus 1 whole cube. Okay, what I am doing here, x minus 3 is x minus 1 minus 2 by x minus 1 whole cube ex dx. Then x minus 1 by x minus 1 का whole cube minus 2 by x minus 1 whole cube, and then ex dx. What do you find? That 1 by x minus 1 whole square minus 2 by x minus 1 whole cube ex dx. Clearly here you see that if fx, since you must have command on differentiation, if your function is this one, certainly its differentiation is minus 2 by x minus 1 whole cube. This is x minus 1 का पावर अगर हम करें तो minus 2, x minus 1 power minus 2, उसका differentiation minus 2 into x minus 1 to the power minus 2 minus 1, it becomes minus 2 by x minus 1 whole cube. So अब यहाँ पर मैं आपके लिए छोड़ दे रहा हूँ कि इसको कर लेना, आप इन दोनों को इंटीग्रेट करना और इसको कैरी फॉरवर्ड करना. तो आंसर आपके क्या आ जाने हैं? ex x minus 1 whole square and plus c, as this is fx and this whole is plus f dash x. Clear? Moving towards the next question. Here it is something different. What is the difference? You will see in the solution that the question is ex e to the power 2x sin x, that is integration e to the power 2x sin x. Now again it is the product of two functions, and there may be one is differentiating and another is integrating, but what we see that sin x का differentiation हो, integration हो, cos में जा रहा है, plus minus sin कुछ भी हो सकता है, और e to x का इंटीग्रेशन हो या डिफरेंशिएशन हो, ये 2x रहेगा ही रहेगा, वो ख़त्म नहीं होने वाला है. तो देखिए इसमें होता क्या है. अगर हम आइलेट को देखें, sin x e to x dx, ओके, माइनस डिफरेंशिएशन ऑफ dx sin x, इंटीग्रेशन ऑफ e to x dx and dx. ठीक. सो हियर इट इज sin x e to x linear in, so whatever the coefficient of x should be divided, minus ddx of sin x is cos x, e to x just we have done now. So what do we find? 1 by 2 e to x sin x minus 1 by 2 e to x cos x. Now again we are here, in place of sin x we get cos x, so integration by parts must be applied here. Going towards 1 by 2 e to x sin x minus half, and now cos x e to x dx minus ddx of what? Cos x, इंटीग्रेशन ऑफ e to x dx and पूरे का dx. ये आपका हो गया पहला पार्ट. चलिए मूव करते हैं 1/2 e2x sin x, यहाँ से फिर आपका e2x का e2x/2 तो -1/4 e2x cos x, ओके, माइनस माइनस प्लस, cos x का डिफ्रेंसिएशन माइनस sin x, सो अगेन माइनस, e2x का इंटीग्रेशन में हाफ आना है और हाफ इधर से, तो 1/4, ओके, एंड देन व्हाट वी हैव e2x एंड sin x dx, जहां से चले वो फिर से आ गया। दैट मीन्स कि अब तो ये लगता है कि अगर फिर से हम इसको इंटीग्रेशन बाय पार्ट्स करें तो फिर वही चीज आता रहेगा, 3-4 स्टेप के बाद फिर से आना है। तो दैट मीन्स देयर इज समथिंग वी हैव टू डू, वी हैव टू रिड्यूस द होल इंटीग्रेशन, होल सॉल्यूशन। हाउ? Just write down here what is this is I, so write down I. Okay, so I'm going to rub the this one. So the answer here start, you can take 1/4 e2x common, 1/4 e2x, then it is 2 sin x minus cos x and minus 1/4 I, I से चलकर यहां तक हम लोग पहुंच गए। रिडक्शन हो गया, रिडक्शन फॉर्मूला की तरह हम लोग इसको यूज करते हैं, रिडक्शन करते हैं जब कभी भी इस तरह के इंटीग्रेशन करते करते वापस फिर से आई आ जाए। अब इसको इधर ट्रांसपोज किया, I प्लस 1/4 I इक्वल टू 1/4 e2x 2 sin x माइनस cos x। अभी हम कांस्टेंट नहीं लिख रहे हैं, बाद में लिख लेंगे। दिस इज 5i/4 1/4 e2x 2 sin x minus cos x, okay, then write down one thing, take 4 cancelled out, 5 is here, so I equal to e2x 2 sin x minus cos x by 5, and now write down your c, where c is constant of integration, okay, where c is constant of integration. So this is another type of questions. Now moving towards another question. Here all are of the same type, or you can say you have to try sin inverse 2x plus 1 by x square, sin inverse 2x plus 2x by 1 plus x square. You can simply say that this is nothing but 2 tan inverse x, 2 tan inverse x. If you put x as tan theta, you will get 2 tan theta by 1 plus tan square theta, this is sin 2 theta. Sin 2 theta, sin inverse of sin 2 theta is 2 theta and 2 theta is tan inverse x. अब इसकी इंटीग्रेशन हो या इसकी इंटीग्रेशन हो, और tan inverse x का इंटीग्रेशन हमने आपको बताया अभी पिछले कुछ मिनट पहले, सो इस क्वेश्चन को भी आप कर सकते हो। नाउ आई एम गोइंग टू मूव इन द नेक्स्ट एक्सरसाइज बेस्ड ऑन द थ्री स्पेशल इंटीग्रेशन, रूट ओवर a square minus x square, integration root over x square minus a square, and root over a square plus x square. So that is the exercise 7.7, and I am going to take one question. Also at the same time I am going to take the supplement dx. What should I have to do? First, make a perfect square, x square plus 4x, x plus 2 whole square. The coefficient of x is 4, 4 का half 2, so x plus 2 का whole square. Now here we get x square plus 4x plus 4, but I have 6, so plus 2, and 2 can be written as root 2 whole square. So it is in the form of x square plus a square dx. Okay, it is in the form of a square, x square plus a square dx, and the integration of this one is nothing but 1/2x root under x square plus a square by 2 log, and then x plus root under x square plus a square, this one. So using this very identity, I can write down that 1 by 2 in place of x is it is x plus 2, and in place of root under x square plus a square, this is whole. First you can say that this is x plus 2 whole square plus root 2 square, and then plus a square. A square is what? Root 2. A square by 2 log x. X is what? X plus 2. And plus root under x square, x plus 2 whole square, root 2 whole square. And plus c, constant of integration. So I have applied the identities. What identities? I have mentioned here just in behind, and then write down that it is x plus 2, और ये जो है वो हो गया आपका ये पूरा एक्स स्क्वायर प्लस 4x. यहाँ से हमने कुछ चूंकि बाहर नहीं निकाला था, प्लस 2, and then plus 2 by 2, that is 1, log x plus 2 and plus root under x square plus 4x plus 6 and plus c, where c is constant of integration. This is very first question. Very in the case you can say I think it is question number 3 of exercise 7.7. After that I'm going to take two or three questions. The next question is question number 5. Question number 5 of exercise 7.7. Root under 1 minus 4x minus x square. Root under 1 minus 4x minus x square. Again, coefficient of x square is minus. So ये h square minus x square में हो सकता है. कैसे करेंगे? ये just see. 1 minus, ये हमने माइनस कॉमन लिया, x square plus 4x हो गया. Okay. Now if here it is plus 4, तो x plus 2 whole square. X plus 2 whole square. So I am going to write down plus 4. You just think about that. This is minus 4. So in this whole expression, I have 1, okay, minus x square, okay, minus 4 is okay, but one more thing is minus 4. So to adjust, we should write down plus 4. So this plus 4 is added in this quantity 5. Are you okay? So here we have a root 5 whole square minus x plus 2 whole square and the whole root under. So again, what is in it is in the form? It is in the form of root under a square minus x square dx. You can say answer should be what? Tell me. What is a square minus x square? As usual, you see that x by 2 root under a square minus x square, and then plus a square by 2 sine inverse x by a and plus c. Okay, well and good. So on the same basis we can write that x is what? X plus 2 by 2 root under, that is root 5 whole square minus x plus 2 whole square, okay, plus a square, that is root 5 by 2 whole square, root 5 whole square, a square, and by 2, and sine inverse x by a and plus c. This identity I have used. So what we find that x plus 2 by 2 root under, the simplified version of this is 1 minus 4x minus x square. देखिए, अगर इसी कंटेंट को रखकर हमने ये बनाया है और कुछ भी बाहर नहीं निकाला, देन राइट डाउन दिस वन. समटाइम्स क्या होता है कि हम कुछ कोफिशिएंट बाहर ले जाते हैं, तब फिर हमें यहाँ सिंप्लीफाई करना पड़ेगा. प्लस 5 by 2 साइन इनवर्स x plus 2 by root 5 and plus c, where c is constant of integration. Am I clear? Now I am going to take one more question, 8. This is root under x square plus 3x, okay, quadratic polynomial. So what we have to do? perfect square, coefficient of x is here 3, so 3 by 2, so it should be x plus 3 by 2 whole square. Done. Okay. Now a plus b whole square, a square, that is x square. Okay, 2 into a into b, 2 into x into 3 by 2, that is 3x. But here I have plus b square, that is 3 by 2 whole square extra. So to cancelled out, we should write down 3 by 2 whole square. So now we are left with, so what we have now x square minus a square dx. X square minus a square dx. What is x square minus a square dx? This is x by 2 root under x square minus a square, and now here it is minus a square by 2. The only identity is with here is minus a square, and the rest log x plus root under x square minus a square. I think this one is the integration. Am I right? So using this one, why we are going to take directly, because in place of x we have a linear factor, linear expression of x with coefficient of x as 1. So if you are going to take x plus 3 by 2 as t, so dx becomes dt. So t square minus 3 by 2 whole square is the same thing. So we can do directly that x by 2, in place of x by 2 is x plus 3 by 2 and by 2 into root under x plus 3 by 2 x square minus a square minus a square by 2 log x, that is x plus 3 by 2 and plus root under x square minus a square. रूट अंडर ये पूरा आप लिख दोगे, ठीक है, and plus c. So what we have that 2x plus 3 by 4 root under, ये कुछ हमने निकाला नहीं है, so it is x square plus 3x, okay, minus 9 by 4 add 2 है तो 9 by 8 log, और यहाँ पर हम 2x plus 3 by 2 ही लिखेंगे और इसको LCM नहीं लेंगे. अगर लेना होगा तो फिर 2 यहाँ आ जाएगा, फिर log 2 को बाहर लेना पड़ेगा. हम यहाँ पर ऐसे ही छोड़ देंगे and plus c. This is answer. ठीक है ना. Now क्वेश्चन हमने ये भी बताया था आपको कि कुछ क्वेश्चन ऐसे भी आ सकते हैं इस फॉर्मेट में जो कि सप्लीमेंट में होना चाहिए. कुछ नहीं है इसमें, बस एक एग्जांपल के तौर पे एक हमने क्वेश्चन लिया, x plus 3 सप्लीमेंट का ही है, 3 minus 4x minus x square dx. ओके, देखिए जब भी लीनियर इंटू क्वाड्रेटिक या लीनियर बाई क्वाड्रेटिक था तो क्या बताया गया था कि लीनियर को इसको इस just we have to split in two forms. One is the differentiation of this one and another is constant. So उसमें बताया गया कि आप क्या करोगे कि इधर लो a into ddx of, ये लो आप dd लिख देता हूँ मैं यहाँ पर 3 minus 4x minus x square and plus b. तो what do we get? a minus 4 minus 2x plus b. सो x का कोफिशिएंट दोनों तरफ कंपेयर करेंगे तो माइनस 2a इज 1, so a is minus 1 by 2, and then constant term is minus 4a plus b, and here constant is 3. So minus 2a is 1, so minus 4 is 2 plus b is 3, so b equal to 1. So we have divided this part as minus half of minus 4 minus 2x and plus 1. You just see whether this whole expression become this or not. I don't know. होना चाहिए. If our calculation is okay, my calculation is okay, then होना चाहिए. Okay. So देखते हैं. Minus 1 by 2 into 4 is plus 2 and plus 1 is plus 3. Minus 1 by 2 into minus 2x is okay, plus x. Now minus half minus 4 minus 2x root under 3 minus 4x minus x square dx one thing, and then plus 1 3 minus 4x minus x square dx another thing. So we have two integration, 1 and 2. In the first one, if you let this as t, you will get dt directly. And the second one, again, as we have done in exercise 7.7, make it a perfect square and go for the kill. Okay? So now, I am going to take this one as minus half t, इसको हमने t ले लिया, तो ये दोनों क्या हो गए, dt में कन्वर्ट हो गए. आप इसको साइड में कर लीजिएगा. Let 3 minus 4x minus x square as t in first integration. In first integration, not in second. Okay. So in that case, we have minus 4 minus 2x dx as dt. Okay, and then plus. इसको मैं क्या कर रहा हूँ, रूट अंडर 3 माइनस कॉमन लिया, एक्स स्क्वायर प्लस 4x हो गया, प्लस 4x तो एक प्लस 4 कर देंगे, परफेक्ट स्क्वायर हो जाएगा. एक्चुअली हमने सब्ट्रैक्ट माइनस 4 किया तो प्लस 4 यहाँ करना पड़ेगा टू मेक अप. And then I can say it is like that one, 3 plus 4 root 7 whole square minus x plus 2 whole square dx, a square minus x square. This is t 3 by 2 plus x by 2 root under a square minus x square plus a square by 2 sin inverse x plus 2 यहाँ x by a and plus c. So this cancel. We have t is what? This one. So 3 minus 4x minus x square to the power 3 by 2 by 3 plus first part. In the second part, x plus 2 by 2, simplified version is what? 3 minus 4x minus x square plus 7 by 2 sin inverse x plus 2 by root 7 and plus c is the answer. If you just go back, you will find that the value of a is minus 1 by 2 I think, and b is plus 1. So here it is minus, हमने शायद छोड़ दिया था, तो this is minus and this is what the answer. तो क्या करना है हमें सप्लीमेंट में, वो आप समझ गए कि अगर कोई भी फॉर्म पी एक्स प्लस क्यू इंटू रूट अंडर ए एक्स स्क्वायर प्लस बी एक्स प्लस सी डी एक्स के फॉर्म में आएगा, जस्ट px plus q divide into two parts. One part is the differentiation of this one and another part is constant. Differentiation part and the function gives you some like this one, and the rest is as we have done in exercise 7.7. so you can do it very much. Okay, so this is what exercise 7.6 and 7.7 I have done today. And after that, if you can ask me about solution of some more, then I can give you, but there should be some practice for you also, so do. And in the next video I will start a definite integral and application of integration, the area bounded regions. In definite integral, three parts are there. First part, just like indefinite integral, and then put the limits, value of limits. Second is properties of definite integral, and one of the third part is integration by using limit of sums. This is the first part in the definite integral, and you can say the before application of integration, that is area bounded region, you can say also in the second choice, you have to do this one. So wait for the next video. I will give maybe today or maybe some day after. Thank you. Bye bye.